uh, or afternoon or whatever day. I don't know. So today's don't have a title on there, but this is graphing quadratics in vertex form. All right, so the first thing we're going to do is we're going to look at the parent function, right? The original graph. So I'm going to take -3 and I'm going to square it. So -3 squared is just 9, right? Notice I put it in parentheses. That's very important, especially if you're using your calculator, right? You have to put it in parentheses because other operations and all that. So you have to put parentheses. -2 squared is 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. And 3 squared is 9. Okay, so we're going to graph this. So we have a 0, 0, a 1, 1, -1, 1, 2 and 4, -2 and 4, and then 9 will not fit. So we'll have to graph that one. And then we know that this is a quadratic function. You're learning that. All right. Uh-oh. Okay. All right. There we go. You see it just moving all around. There we go. Okay, here we go. So how is this different from before? So in our previous lessons, we have graphed linear and absolute value equations, right? And linear resulted in a straight line. Absolute value resulted in two straight lines, right? We had the regular side, like we have right here. And then this side, because it was absolute value, it changes those negative y's to positive y until it flips back up. But notice they're both straight line. Quadratics, and they move on a one-to-one rate. Quadratics don't do that. Quadratics start to increase rapidly, right? We go from -4 and then to 16, -5 and then 25, 6 to 36. Like those numbers change quickly. And so that's what makes it have its curve shape, is that it's starting to speed up in the y the output area. Okay, so then we have this word bank that we're going to use today that's going to add to our lessons. So the first part is a vertical shift, vertical compression, vertical stretch, right? That word vertical, it's going ups and down. This part all talks about Y's. So it's good to know that this is the Y section of the graph. And then you can see I highlighted that reflection over the x-axis. So what does that look like? So I have my quadratic function, right? I have y equals x squared, and it looks like this. We just graphed it. Well, what happens when I have y equals -x squared? Well, this equation now flips over. I don't know if I'm gonna be able to flip it. It flips over, and it no longer goes straight up. It is now going straight down. Right? It flips over the x-axis, but it changes the outputs of the y's, right? The y's change. So let me show you graphically what happens. So -3. So what does this look like? I'm going to put -3 squared. That becomes a 9, but then I attach that 9 negative. So notice how the outputs, the y's, are actually the ones that's changing. They are now being positive or negative. So that's what's changing when we have this negative. So what causes all of these vertical shifts up and down? It happens when we're adding or subtracting a number. When you add or subtract some number. Vertical compression happens when you are dividing by a number, or we're going to be multiplying by a number less than 1. Okay. Vertical stretch is when we're multiplying by a number greater than 1. And then reflection over the x-axis is when you have a negative number. Negative, not a minus, it's a negative. Okay. So all of those things reflect the output, the Y part. And you're gonna be able to see like quickly like what's happening. And it's gonna it should make some sense, especially because it's gonna be a build of all the things we've done before. Okay, so then horizontal shifts. Well, if all the vertical stuff is with Y, the horizontal stuff has to be your X's. And it repeats the same thing. This is when you add or subtract, when you're dividing or multiplying by a number less than one. Horizontal stretch when you're multiplying by a number greater than one. And a reflection over the y-axis is this time when you have a negative with the x stuff. And that one's a little bit tougher to show because like if this is this is the graph, right? This is our, I should do it different color. This is our graph. And so all it does is switch these 2 points. So it's really hard to show that it's switching those two numbers because they're symmetrical. But there's going to be a time where it's a lot easier to see and you'll see the effects of it. Okay, so now what? Let's just do this problem. Now, we have graphed these type of problems before when we graphed. You don't have to write this down, but when we graphed, well, let me start all over. We recently worked on standard form. Standard form looks something like this. I'm sorry, I'm doing some math in my head. Positive 4, negative 12, negative 16. Okay, that's standard form. Okay, and it's actually standard form from this equation. I tried to work it out real fast. Oh, maybe I didn't. I messed up a number here. There we go. I think that's right. Okay, so this is standard form for a quadratic function, for that quadratic form. Notice it doesn't have any parentheses. So the method in which we solved this one, how we did ABC, we can't do here. We can't do the ABCs because it's not in the same format. So not this form. It's a different method. Okay, but just a second ago, I told you we worked on point slope form. That's point slope form. How do I know it's point slope form? Doesn't have a squared, right? And that's going to be our biggest takeaway. When you guys are noticing it, you can be like, what do I do with this square? Well, the squared lets us know what kind of function it does, it has, and it tells me the effects that we have on the numbers, like our table, how our tables were different for all of them. Um, and it lets me know that we're talking about a quadratic, or those are the things that those numbers do. But for how we graph them, it's going to be the same process that we did with point slope. What about when we did absolute value? When we did absolute value, it was the same process, right? Same, look at the method. Look at the way they set up. The only difference is that's parentheses squared, that means quadratic. Just a parenthesis, that means linear. Absolute value, that means it's going to be the V shape, absolute value bars, right? That's all of this, though. It looks the same exact way. We're going to graph these the same exact way we've done before. So you can go back to your notes and look at it. So what did we do? The first thing we do is move the y's with y's, move the y stuff. Anything that has to do with y's, we're going to move that. So how do I do this? I'm going to add 4, and then I'm going to divide by -3. And it has to be in that order because that's the order we solve in. So I'm going to take y, I'm going to add 4, and then I'm going to divide by -3. And that is the y part. So how do I know which stuff to move? If it's in parentheses, little note, parentheses is all your x stuff. Anything outside the parentheses is all your y stuff. Cool beans. Then what we do? We make our table. Now we already have our parent function of our table. Remember, our goal is to actually manipulate it into the new equation to see how does these numbers affect our new graph. And that's what we're doing. We have our original graph, which is -3, -2, -1, 0. Okay, I think that's enough. So -3, -2, -1, 0, 1, 2, and 3. And then it's going to be 9, 4, 1, 0, 1, 4, 9. So that's the original function, right? That's not going to change. So we write that down. And then we want to see how are these numbers manipulating our graph to form our new equation. And so we set it up. We go y plus 4 divided by -3, and we pick one of the y values. It has to be a y value. If it's not the y value, then we're going to get it wrong. Okay, so I picked the y value. So we're going to put y equals some number, and then we solve. So how do we solve this? We multiply by -3, and then we minus 4. So that's exactly what we're going to do to our table. The first thing we're going to do is multiply by -3, and then we're going to subtract 4. And we're going to do that to every number for the y part of our table. Okay, so that's how we solved it. That's what we do to it. So 9 times -3 is -27, minus 4 is -31. 4 times -3 is -12, minus 4 is -16. 1 times -3 is -3, minus 4 is -7. 0 times -3 is 0, minus 4 is -4. 1 times -3 is -3, minus 4 is -7. 4 times -3 is -12, minus 4 is -16. 9 times -3 is -27, minus 4 is -31. So the way I solved it, I applied to all of those graphs. Okay. Actually, I need to move this down one. I'm not going to have room to do one last part. Sweet. So why did I introduce these word bank to you? Well, we just discovered what's happening algebraically to our graph, but now we need to talk about what's happening physically to our graph. So the first thing we did was multiply by a negative. Well, the fact that I heard multiply by a negative, there's two things that stick out. Multiply means I have so multiply and it's greater than 1. So it means I have a vertical stretch. So I have a vertical stretch by 3. What does that mean for us? Where this point right here was this point right here, which is really 1. So looking right there, it was at 1, 1. It is now going to be multiplied by 3. So it's going to be at 1, 3. This makes our graph taller. So this graph will start to look like this. It'll get taller and skinnier because we're pulling it apart, we're stretching it. Okay, then what happened? Well, then we said -3. So that means there's a reflection over the x-axis. So what does that mean again? So again, I'm going to take this graph and I made it taller, right? So I put these dots here. Oops. I put a dot here and here. I made it taller, but then I'm going to flip it over the x-axis. So now it's going to be here, here, and here. It's going to go this way at this point. So that's it's stretched out and flipped over the x-axis. That's how it's moving. And then what happens? Well, then I said subtract 4. Subtract 4, that's a minus, right? That's going to shift down, vertical shift. We got to make sure we're plain. Vertical shift down 4. Again, so we'll start all over. This graph was grew uh, up here, right? It was stretched 3 times longer. Then we flipped it over the x-axis, and then we moved it down 4 spaces. 1, 2, 3, 4. So now our graph is there. That's what that means. So that's the physical of what's happening to our graph. If I was to move it over time, I get to see what's happening. But we're not done yet. We still have to do the x values. So now I'm going to take my x equation. X minus 2 equals, pick an x value, -3. And I have to add 2 to both sides. So that means for this entire table, I'm going to add 2. So my x values is going to be -3 plus 2 is -1. -2 plus 2 is 0. -1 plus 2 is 1. 0 plus 2 is 2. 1 plus 2 is 3. 2 plus 2 is 4. 3 plus 2 is 5. Okay. And then we talk about the transformation. Well, I added 2. So this is a horizontal shift. right 2. And it's right because we had a 2. So then, so what was to happen? Okay, so we go back to this graph here. We stretched it, we flipped it, we moved it down, and we were here, right? So now what do? We take this entire graph and we're going to move it to the right 2 spaces. So that means our graph goes like this. That's what that means in all the words. So let's see if we do that. Let's graph those points and see, do we end up in that spot? Now I can't graph -31, -16, or I can do -7. So it's going to start there. I'm going to start at negative or +1, -7. All right. So net +1, -7 is here. And then 2, -4, 3, -7. And that's it. That's the only ones I can graph. Hey, that's exactly where we said it was going to be. Remember, do it one more time. We stretched it, we stretched it, we flipped it. So that's here. And then we moved it down 4, 1, 2, 3, 4, and then we moved it right to 1, 2, and that's exactly where we landed. Look at that. So same things. That's all we're doing is applying the transformations to this as well. Okay, so let's keep going. So we're going to do number 2. So number 2, we're going to again rewrite this so that our y stuff is with our y stuff. Oh wait, we did our x equals some numbers, so we solved that, and then we did our transformations, and then we graphed it. Okay. So there's nothing in parentheses. I'm guessing all this stuff belongs to y. How do we solve this? I add 1 to both sides, so y plus 1. And then I'm going to have to multiply by -2. Okay, so it's just solving capabilities. I have to be really strong. Do 1-step, 2-step equations. That's really what we're solving here. Okay, let's make our table. So we have x, excuse, x and y. And oopsies, let's erase it. There we go. So we have -3, 9, -2, and 4, -1, 1, 0, 0, 1, 1, 2, 4, 3, and 9. Okay, so let's talk about the first one. We have -2 times y plus 1 equals 9. How do we, oh, I'm gonna pick an easier number. I'm gonna pick 4 because it's divisible. So 4 divided by -2. So we're gonna divide by -2 first, and then we subtract 1. So then we minus 1. So here's my y values. I'm going to do what I just said. I'm going to divide it by -2, and then I'm subtract 1. So this is -11/2. Divided by -2, and then subtract 1. Divided by -2, so -1/2, minus 1, -3/2. Divided by -2, which is 0, minus 1 is -1. Divided by -2, so -3/2. Divided by -2 is -2 minus 1 is -3. And then divided by -2 minus 1 is -11/2. There we go. Now the x values. I set the x equals, so I have x equals. I'm not caring about the squared, right? 'Cause we already know the squared lets us know it's quadratic. That's why we have our table. So now we're just manipulating the stuff that was our table. X equals -3. There's no math to do there. So that means all my x values stay the same. -3, -2, -1, 0, 1, 2, and 3. Okay, so now what? Let's talk about a transformation. The first thing we did was divide by 2. So dividing, right? So that means it's a vertical compression. Um, this time, instead of saying dividing by 2, remember, we like to say multiplying better. So vertical compression of 1/2. So dividing by 2 times 1/2 are the same thing, right? So we're going to write 1/2 instead of dividing by 2. and then what? So vertical compression it says -2, so that means it reflects over the x-axis, so it's going to go downward. And then what's next? We subtracted 1, so it's going to go down 1 space. Oh, let me do a vertical shift down 1. Vertical shift down 1. And then what's x? That x doesn't have anything, so it stays the way it is. So let's graph everything. I'm gonna graph the whole numbers. So -2, -3, 0, -1, 2, -3. Think that's gonna make my life a little bit easier. So 2, -3, and there we go. That's our graph. Awesome. Okay, that's it. That's all. Like, so it's the same stuff we've been doing. We're just adding these words, and again, use your word bank. Okay, so for the last two, I'm going to just do them and then I'm going to post it to see if you got it correct. Okay. Okay. How did you do? A lot of work on here. Some of the things like, making sure you put your compressions and stretches a lot easier. The math here. Right. At some point, hopefully you do get better at it. You're not actually working all that out. Right. I worked it out because I'm showing you the answers to make sure you did solve them correctly. I know in class had a few students who thought they should multiply by 2 first instead of adding 2 first. That's the only reason I work it out. But at some point, you should get better and better at solving equations that you're not actually trying to work everything out. All right. If you have any questions, just let me know. Talk to you later. Bye. Bye.